from page 107 to 115. Page 107. Light, shadows and reflections. We see so many objects around us. On the way to school, we see things like buses, cars, cycles, trees, animals, and sometimes flowers. How do you think we see objects? Think of the same places at night time if it were completely dark. What will you see? Suppose you go inside a completely dark room. Are you able to see any objects in the room? But when you light a candle or a torch, you can see the objects present in the room, isn't it? Without light, things cannot be seen. Light helps us see objects. The torch bulb is an object that gives out light of its own. The sun is another familiar object that gives its own light. During the day, its light allows us to see objects. Objects like the sun that give out or emit light of their own are called luminous objects. What about objects like a chair, a painting, or a shoe? We see these when light from a luminous object like the sun, a torch, or an electric light falls on these and then travels towards our eye. (11.1) Transparent, opaque and translucent objects. Recall our grouping objects as opaque, transparent or translucent in Chapter 4. If we cannot see through an object at all, it is an opaque object. If you are able to see clearly through an object, it is allowing light to pass through it and is transparent. There are some objects through which we can see, but not very clearly. Such objects are known as translucent. Activity 1. Look around yourself and collect as many objects as you can. An eraser, plastic scale, pen, pencil, notebook, single sheet of paper, tracing paper or a piece of cloth. Try to look at something far away through each of these objects. Figure 11.1. Is light from a faraway object able to travel to your eye through any of the objects? Record your observations in a table as shown in Table 11.1. We see that a given object or material could be transparent, translucent, or opaque, depending on whether it allows light to pass through it completely, partially, or not at all. Figure 11.1 shows you are given a table which is divided into 3 columns. One is for object or material. Second is for view through the object possible, fully, partially, or not at all. And the third one is for object is opaque, transparent, translucent. Objects are pencil, rubber ball, sheet of writing paper. Complete this table according to your observation. (11.2) What exactly are shadows? Activity 2. Now, one by one, hold each of the opaque objects in the sunlight slightly above the ground. What do you see on the ground? You know that the dark patch formed by each on the ground is due to its shadow. Sometimes you can identify the object by looking at its shadow. Figure 11.2. Spread a sheet of paper on the ground. Hold a familiar opaque object at some height so that its shadow is formed on the sheet of paper on the ground. Ask one of your friends to draw the outline of the shadow while you are holding the object. Draw outlines of the shadows of other objects in a similar way. Now ask some other friends to identify the objects from these outlines of shadows. How many objects are they able to identify correctly? Do you observe your shadow in a dark room or at night when there is no light? Do you observe a shadow when there is just a source of light and nothing else in a room? It seems we need a source of light and an opaque object to see a shadow. Is there anything else required? Activity 3. This is an activity that you will have to do in the dark. In the evening, go out in an open ground with a few friends. Take a torch and a large sheet of cardboard with you. Hold the torch close to the ground and shine it upwards so that its light falls on your friend's face. You now have a source of light that is falling on an opaque object. If there were no trees, building, or any other object behind your friend, would you see the shadow of your friend's head? This does not mean that there is no shadow. After all, the light from the torch is not able to pass through his body to the other side. Now ask another friend to hold the cardboard sheet behind your friend. Is the shadow now seen on the cardboard sheet? Thus, the shadow can be seen only on a screen. The ground, walls of a room, a building, or other such surfaces act as a screen for the shadows you observe in everyday life. Shadows give us some information about shapes of objects. Sometimes shadows can also mislead us about the shape of the object. In figure 11.4 are a few shadows that we can create with our hands and make believe that they are shadows of different animals. Have fun. Activity 4. Place a chair in the school ground on a sunny day. What do you observe from the shadow of the chair? Does the shadow give an accurate picture of the shape of the chair? If the chair is turned around a little, how does the shape of the shadow change? Take a thin notebook and look at its shadow. Then take a rectangular box and look at its shadow. Do the two shadows seem to have a similar shape? Take flowers or other objects of different colors and look at their shadows. A red rose and a yellow rose, for instance. Do the shadows look different in color when the colors of the objects are different? Take a long box and look at its shadow on the ground. When you move the box around, you may see that the size of the shadow changes. When is the shadow of the box the shortest? When the long side of the box is pointed towards the sun, or when the short side is pointing towards the sun? Let us use this long box to prepare a simple camera. Page 110. 11.3. A pinhole camera. You might think that we need a lot of stuff to make a camera. Not really, if we just wish to make a simple pinhole camera. Activity 5. Take two boxes of cardboard such that one can slide into another with no gap in between them. Cut open one side of each box. On the opposite face of the larger box, make a small hole in the middle. Figure 11.5a. In the smaller box, cut out from the middle a square with a side of about 5 to 6 cm. Cover this open square in the box with tracing paper or translucent screen.
Figure 11.5b. Slide the smaller box inside the larger one with the hole in such a way that the side with the tracing paper is inside. Figure 11.5c. Your pinhole camera is ready for use. Hold the pinhole camera, look through the open face of the smaller box. You should use a piece of black cloth to cover your head and the pinhole camera. Now try to look at some distant objects like a tree or a building through the pinhole camera. Make sure that the objects you wish to look at through your pinhole camera are in bright sunshine. Move the smaller box forward or backward till you get a picture on the tracing paper pasted at the other end. Are these pinhole images different from their shadows? Look through your pinhole camera at the vehicles and people moving on the road in bright sunlight. Do the pictures seen in the camera show the colors of the objects on the other side? Are the images erect or upside down? Surprise, surprise! Let us now image the sun with our pinhole camera. We need a slightly different setup for this. We just need a large sheet of cardboard with a small pinhole in the middle. Hold the sheet up in the sun and let its shadow fall on a clear area. Do you see a small circular image of the sun in the middle of the shadow of the cardboard sheet? Look at these pinhole images of the sun when an eclipse is visible from your location. Adjust your pinhole and screen to get a clear image before the eclipse is to occur. Look at the image as the eclipse begins. You will notice a part of the image of the sun gradually becoming darker as the eclipse starts. Figure 11.5 ABC. Page 111. Never ever look directly at the sun. That could be extremely harmful for the eyes. There is an interesting pinhole camera in nature. Sometimes, when we pass under a tree covered with large number of leaves, we notice small patches of sunlight under it. Figure 11.6. These circular images are, in fact, pinhole images of the sun. The gaps between the leaves act as the pinholes. These gaps are all kinds of irregular shapes, but we can see circular images of the sun. Try to locate images of the sun when an eclipse occurs next. That could be so much fun. Bujo has this thought. We saw upside down images of people on the road with our pinhole camera. What about the images of the sun? Did we notice them to be upside down or anything like that? Paheli has another thought. Surely all these results that we are seeing, formation of shadows and pinhole images, are possible only if light moves in a straight path. Figure 11.6 shows a natural pinhole camera.